What's going on? This is Unit 13 test. Hey, your last test of the semester, man. Fingers crossed, hope you do well. We're almost there. Almost there. Hey, make sure you put the work in. Pass this test, man. Pass this test. Go out with a bang. Alright guys, man, first off, my voice is depleted. I've been high energy on the field lately, so if I sound a little groggy, man, it's just my voice is gone from all the intense passion I've been exuding on the field, man. But anyway, man, let's go ahead and get into this math, man. Hey, really wish you the best on your test, alright? This first example here, we're looking at alright guys, this first problem right here, man, we're given f of x, which is x squared minus 25, and we're given g of x, which is x squared minus 8x plus 15. Find these functions. So here we need to find the function f plus g of x. Alright, this just means it's evaluated in terms of x, guys. This is not a foiling problem where I foil x. Alright, or you can look at it like this. If you did want to take that approach, f of x plus g of x. Alright, if you were to foil the x, you'll have f of x plus g of x. But guys, all you need to know is, look, this is all it is. The function f of x plus the function g of x. Alright, so if I take this function and I'm going to add the function g of x, like so, guys, what we're going to do is combine like terms. So I have 1x squared plus 1x squared, that's 2x squared. I know some of you guys are like, hey man, where'd that 1 come from? Guys, the 1 is always there. The 1's always out in front. So x squared plus x squared is 2x squared. Now I have this single term, this single monomial of x, so minus 8x. And then I have negative 25 and 15 are my constants. So negative 25 plus 15 is going to be a negative 10. Alright, this guy's right here is 2x squared minus 8x plus, minus 10, okay? Moving along, man, right here. We have f minus g of x. Or you can say f of x minus g of x. Alright, now the one thing you must remember is, y'all see that minus? You got to distribute that to g of x. So if you take f of x minus g of x, alright, you got to distribute that negative, guys, to this whole thing, so it'll look like this. X squared minus 25 minus x squared plus 8x minus 15. Alright, distribute the negative. So anyway, here's what we got. X squared minus x squared is 0, so there's no more x squareds. Negative was, let's see, we have positive 8x. And then we have negative 25 and negative 15, which will give us a negative 40. Alright, so here we go. 8x minus 40. Alright, next we have, guys, f times g. Alright, or f of x times g of x, okay? Now, it's multiplication, which means you're going to have to FOIL. So if I go x squared minus 25, and we multiply that to x squared minus 8x plus 15. Let me make sure I was right. Yep. Alright, what you got to do is, I think personally, you should break this up into two different problems. To have x squared times x squared minus 8x plus 15. Alright, because this is essentially what you do when you FOIL. And this side, this is minus 25. So negative 25 times x squared minus 8x plus 15. Alright, so that way It's just distributing then. All right, you don't have to worry about fully, first, outside, inside, last, all that stuff. Okay. So with that being said, man, let's have a look. All right, so now we can go ahead and multiply like this, guys. So you have x squared times x squared. That's x to the fourth. X squared times negative 8x is negative 8x cubed. And x squared times 15 is a positive 15x squared. Now I'm going to do this side with the negative 25. Negative 25 times x squared is negative 25x squared. Negative 25 times negative 8x is going to be a negative, no, actually a positive. Negative times negative is a positive 200x. And then negative 25 times positive 15 is going to be negative 375. Now from there, guys, we just combine like terms. X to the fourth is the only fourth term. Negative 8x cubed is the only cube term. All right, we have these two squared terms right here. So 15x squared minus 25x squared is going to be negative 10x squared. And then you have this single x term, so 200x, and that's the only constant, 375. So there you go right there, guys. All right, here's your final answer. Your final polynomial when you multiply f of x times g of x, okay? Now, guys, let's take a look at number 4. Number 4 says f divided by g. All right, so again, that's f of x divided by g of x. All right. So with that being said, we have x squared minus 25 divided by x squared minus 8x plus 15. Now, before we begin, whenever you have division, guys, you need to factor as much as possible. So I'm going to factor the top. The top is the difference of two squares. All right, so the two values that multiply to give me x is x and x. The two factors that multiply to give me negative 25 is 5 and negative 5. All right, so what we have here is x plus 5. So you have x and a positive 5. And right here you have x minus 5. That's the difference of two squares. Down here at the bottom, we got to think of two factors that are multiplied to give me 15, but also add to give me negative 8. Those factors are what are multiplied to give me this, 15, negative 5, and negative 3. Sorry about that. Well, if I add those same two numbers, negative 5 minus 3 will give me negative 8. So we have x minus 5, and we have x minus 3. So now, guys, that we have our terms factor, we can cancel a term out. And in this case, we have x minus 5 at the top and x minus 5 at the bottom. Those are canceled, guys. So what's remaining is going to be x plus 5 at the top and x minus 3 at the bottom. Now, we've got to do one more thing. We've got to figure out where this thing is undefined. All right. Where is it undefined? You've got to take the denominator and set it not equal to 0. Because if you remember, anything over 0 is undefined. This is undefined. So what will make this bottom 0? Well, if I take it and set it not equal to 0 and solve it, add 3 on both sides, you get x not equal to 3. All right. And my point in saying that is this. Let's put 3 right here in place of x. All right. If I had 3 minus 3, I would have 0. So I would have x. I would have 3 plus 5 and 3 minus 3. So 3 plus 5 is 8 over 0. Guys, 8 over 0 is undefined. So 3 will make this whole thing undefined. So we're going to say here's the answer. All right. Comma, where x is not equal to 3. Final answer right here, guys. All right, let's keep going. going to evaluate some composite functions here. F of x is 2x minus 5. G of x is 2x squared. Here we're going to evaluate f of g of 5, meaning we need to evaluate this inside term first. All right, inside term first. So the inside term is g. We're going to evaluate that for 5. So we're going to go g of 5. All right, we're going to plug that 5 right there, guys, where that x is. So we have 2 times 5 squared. Well, 5 squared is 25. And 25 times 2 is 50. So now we take this answer right here. We know that this right here is 50. G of 5 is 50. So that means we're going to evaluate f of 50. All right. So we have f of 50 equals, and we're going to put that 50 right there. So you have 2 times 50 minus 5. So 2 times 50 is 100, and 100 minus 5 is 95. Therefore, guys, this equals f of g of 5, 95. Alrighty, moving on. Here, we're going to evaluate f of, g of f of 3. So we're going to evaluate the inside term first. So with that being said, the inside term is f of 3. So we're going to evaluate f for 3. So we're going to put the 3 right here where x is. So f of 3 equals 2x, x is 3. So we have 2 times 3 minus 5. 2 times 3 is 6. 6 minus 5 is 1. So now we know that this f of 3 is 1. So we're going to evaluate g of 1. So we have g of 1. We're going to put 1 right here. So you have 2 times 1 squared. 1 squared is 1 times 2 is 2. Therefore, g of f of 3 equals 2. Now find f of g of x. What's the domain of f of g of x? This right here is a composite function. Notice, guys, we are not evaluating x for anything other than x. All right, so x is x. So what this means is, and how I like to draw it is, let me clear this off so I can give you a little more visual. For this problem right here, the inside function is going to be plugged into the outer function f. So I'm going to take this and I'm going to plug it in right there. All right, so this is no longer x. This x right here will now be this function. And here's what I mean. See how this is 2 times x minus 5? Well, again, this is no longer x. What we're going to do is substitute the internal function in this place, 2x squared. Like that, in place of x. So put that function where that x is. Now evaluate it and simplify. Right here we can multiply these two, so 2 times 2x squared is 4x squared minus 5. This is it. This doesn't simplify anymore. This is what we get for this problem right here. I'm sorry, I'm writing all this up here. I don't want to confuse anybody. This is number 8, guys. Then it says, what is the domain? Well, guys, this is a quadratic. All right. Now, because this is a domain, because this is a quadratic, guys, the domain is all real numbers. All right, a quadratic, if you remember, this parabola doesn't stop getting wide. It's going to infinitely get wider and wider. It'll never stop getting wider, okay? So the domain is all real numbers. Over here, f of g of x. All right, meaning we need to take the function the function f and plug it into g. So the function g is 2x squared, right? Well, in place of this x, we're going to substitute the function f. So it will look like this. I'm sorry, I forgot what the function was. Yeah, 2x minus 5. Sorry, I put x minus 5. So let me go back. There we go, 2x minus 5 goes in place of that. All right. Now, some of you guys may be tempted to get here and go, I'm going to distribute. You can't do that because this square right here. All right. This square says I need to multiply this binomial twice. So what you have to do is FOIL that out. So you have 2 times 2x minus 5 times 2x minus 5. Alright, again, this square tells me I need to expand this binomial. Alright, so when I do that and FOIL this, what I get is 2 times, now folding this part, 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times positive 2x is negative 10x. And negative 5 and negative 5 gives me a positive 25. Alright. So now from there, I'm going to simplify that part to have 2 on the outside times 4x squared minus 20x plus 25. Plus 25. Now, the last thing I'm going to do is distribute the 2 to give me a total of 8x to the 4th. I'm sorry, 8x squared. I don't know why I made that a 4th. 8x squared minus 40. There we go, 40x plus 50. Okay. There we go. Let me see. Yeah, that looks good, man. 8x squared minus 40x plus 50. Guys, this is g of f of x, okay? Right here. And that is number 9. Now, moving on to number 10. Number 10, guys, this problem says from the graphs below, determine if part A, the relation shown is a function. So we got to tell if it is a function, and part B, if the inverse is a function. Now, remember to tell part A, if you want to know if it's a function, you use the vertical line test. So I'm going to draw a vertical line. All right. Now, with those vertical lines I just drew, notice that it crosses that green function twice. All right, let me make this a little bit bigger. It crosses it twice, and because it crosses more than once, it is not a function. So part A, is it a function? No, it is not a function. It failed the vertical line test, okay? Now, for part B, to figure out if its inverse is a function, what you're going to use is the horizontal line test. All right, so I'm going to use the horizontal line test like this. All right, now, as you can see, with the horizontal line test, those lines only cross that function once right there, once right here. So the inverse of whatever that function is a function. Right, this inverse is a function. All right. Now let's go over here to 11. Part A. Part A, is this a function? How do you test to see if this is a function? You use the vertical line test. All right, so doing the vertical line test, here we go, vertical line. All right, notice that vertical line only touches once. So we can assume, or we know, that this is a function. Now we gotta look at part B and determine if the inverses are functions. So when we do that, we use our horizontal line test. I'm just gonna sketch them out, horizontal line. Notice the horizontal line only touches once as well. So the inverse is a function as well. Alright, there's a function as well, okay? Now, over here it says find the inverse. For number 12, when you find the inverse, step 1, swap x and y. Alright, swap x and y. So I'm going to rewrite this in terms of y so you guys can understand what I mean. Y equals x squared plus 1. So now step 1, swap x and y like this. Alright. And now step 2 would be to solve for y. So I'm going to solve this whole thing for y. Meaning I'm going to subtract 1. So that leaves me with x minus 1 equals y squared. And then we're going to take the square root on both sides because I need to get rid of that square right there. So the square and the square root is going to cancel. And now the one thing that we have forgotten, I think, man, is the plus or minus. All right, when you take the square root on both sides, you have plus or minus. The square root of x minus 1 equals y. That's our inverse right there. All right, y by itself now. All right, so let me backtrack one time. When you solve it, it equals y. Okay. Now, I'm going to say that the inverse, the y inverse, is plus or minus the square root of x minus 1. Or you could say the inverse function is plus or minus x minus 1. All right, or square root of x minus 1, sorry. Right there, okay? 13, same thing. Step 1, swap x and y. All right, so you have x equals 4y minus 2. Then we're going to solve for y. So we're going to add 2 on both sides. So you have x equal, I'm sorry. X plus 2 equals 4y. So now we need to divide by 4 on both sides. All right, so we end up with x plus 2 divided by 4 equals y. All right, now that y is isolated, we can say y inverse is x plus 2 over 4. Or you can say the function inverse equals x plus 2 divided by 4. All right. Okay. Number 14. Let me erase. I don't want any overlap. Number 14 says, which polynomial would best fit the data if it had a constant first difference? That's linear. All right, a constant second difference is quadratic. A third difference is cubic. A fourth difference is quartic. And a constant ratio is exponential. Alright, constant ratio, exponential. Now, the regression model fits data perfectly is 1. Alright, 1, that's when your R squared equals 1. And with that, R squared comes from the calculator. A model that at least fits data, the value is closer to 0. Alright, that's when you have all those decimals, guys. It's closer and closer to 0. Alright, now, it says use a finite or ratio to determine the degree of the polynomial that best fit the data, then calculate. Then, hold on. Use your graphing calculator to write the polynomial function that best fits the data. Alright, here's what we got. First, I'm going to just try to figure out, man, if there's a common difference here. -5, if I wanted to go 2 minus a -5, that's a distance of 7. 3 minus 2 is 1. 4 minus 3 is going to be 1. And 11 minus 4 is going to be 7. Alright. So now 1 minus 7 is -6. 1 minus 1 is 0. 7 minus 1 is 6. So now, guys, 0 minus 6, or 0, excuse me, the distance here is 6. The distance here is 6. Alright, that's the third difference. So this is cubic. This is cubic. Alright, if I wanted to find a function, I'll show you how to use your calculator. Alright, so here on the calculator, guys, what you're going to do is you're going to press stat, and you're going to hit edit, then you enter your data like this. List 1 will be column X, list 2 will be column Y, like this. Alright, now we found the difference was cubic, okay? So if I go stat and then write to calculate, here are all my functions right here, my regressions. So we had cubic, option 6. And there, guys, is going to be my equation. Y'all see how R squared is 1? So this is definitely our function. Okay. Hypothetically, this is strictly hypothetically. Let's say I did quadratic. Alright, quadratic, option 5 right here. Alright, I just wanted to show you how, again, see, R squared is not quite 1. Okay. So that tells me that this isn't the equation I need versus the other one. So let me go back to cubic. And we're going to have our equation. So our equation, A is 1, B is 0, C is 0, D is 3. So I'm going to end up with 1x cubed plus 3. All right, so that's our equation. Let me go back to what we were working on. So the equation is 1x cubed plus 3. Or you can simply write x cubed plus 3. Alright. X cubed plus 3. And I think that will suffice right there, alright? And if you need to check yourself, you can, guys. Alright, like if I took -2. -2 cubed is -8. -8 plus 3 is -5. So that checks out, you know. Alright, let's have a look at this next one. Now for this next one, guys. Alright, the first one I demonstrated how to do it by hand. This next one, man, these numbers are a little more funkier. Alright, so I'm going to use the calculator exclusively for this one. And I want to show you how to do it. So let's have a look, man. With the calculator, I'm going to go and put those points in like this. So again, you would go stat, then edit, and then you would enter your data into the calculator like this. Alright, and now we're going to go stat and calculate. And we want to calculate all, let's see, I'm assuming it's not linear. There's no constant pattern off the bat. Quadratic, I don't think it's quadratic because that's negative squares. All right, so I'm gonna check cubic. Let's look at the R squared. R squared is 0.999. That's pretty close to 1. All right, let me check the next one. Let's check quartic and see what we get. Option 7 here. All right, here, R squared is 1. So this tells me that this is a quartic function. Okay, so we can take that and write our equation down based off this deal here, man. So let's see here. I'm gonna go back to the page we're working on now. And so our equation that we came up with, we know that this is quartic. All right, and we had negative 0.0. Actually, I'm gonna round this to 2 decimal places. So negative 0.1. Man, that's random. Negative 0.1. X to the 4th, all right, plus 2.88 x cubed minus 17.6 x squared plus 35.5 x minus 34. And that, guys, is our equation for this here, guys. Now, let's look at this next one. Looking at this, guys, let's see, can I make a ratio? Because I don't see a constant pattern of increasing or adding and subtracting. So, a ratio, like if I went 96 divided by 24, that's 4. All right. And 6 times 4 is 24. All right. 1.5 times 4 is 6. So I assume 3.75 times 1.5. 3 times 4 is 1.5, excuse me. All right, so I'm going to go ahead and say this is exponential, guys. All right, this is exponential. Now let's check it with our calculator. Again, we're going to go to the calculator and enter our data. We have the information in the calculator. So now what you're going to do is go to stat again and calculate, and you're going to go all the way down to option 0. And of course, they don't have a 10 over here, so they put 0, which is exponential regression right here. So hit enter right there, man, and we're going to see if this is exponential. Boom, there we go. All right, as you can see, R squared is 1. So our equation is 1.5 times 4 to the x, all right? So we have 1.5 times 4 raised to the x, all right? Now, down here it says use logarithmic regression, guys. I underline that and emphasize logarithmic because some of you guys are saying, but I don't know what this is. Guys, it's logarithmic. It tells you it's logarithmic to find a function that models this data. Now, the first thing I want to point out is remember that this must be, logarithmic data must be in the form a plus b ln of x. All right, a plus b ln of x. So let's go and enter this into our calculators. So once the data is in like this, guys, we're going to press stat again and go over to calculate, and you want to go to natural log regression, which is 9. All right, you're going to go to 9, guys, right here. ln, natural log. All right, and we're going to hit enter on that, guys. Calculate, and we get 1.14. I'm going to go 2 decimal places on this. So 1.14 and 8.41. All right, I know R squared is 0.99 here, but guys, again, it told us it was a logarithmic regression. So 1.14 and 8.42. So the equation again is 1.14 plus 8.42 ln of x. All right, so again, we made our model. All right, we just made an equation, okay? Now it says find the missing value if f is exponential. All right, if it's exponential, remember, if it's exponential, you have a common ratio. You have a common ratio. So the easiest way to do that is just figure out the ratio of the other ones. All right, so if I take the last two here that's given, all right, and we figure out the ratio, if I went 364.5 and divided that by 121.5, that gives me a ratio of 3 over 1. All right, you can do that in your calculator. You'll get 3. All right. So since I know that's 3, all right, if I take this term, 13.5, and multiply by 3, it'll give me 40.5. All right, 40.5. Now, it says use the exponential regression model to find the function that models the data. So we're going to find the function. We're going to take this and enter it into the calculator like so. All right, so once our data is in, we're going to press stat and calculate, and we're going to do exponential regression again. And guys, that's option 0. All right, right, oh, passed it. You know what, I'm going to just hit 0. And there we go. All right. Exponential 118.9 and 1.75. All right, so there we go. There's our function. Now it says estimate the population when the bacteria this population at 12 minutes. All right, so to estimate this at 12 minutes, I'm going to take my equation and I'm going to put it back into my calculator. All right, or actually, you know what? I'm going to solve this. I'm just going to solve it. Check this out. We want to know estimate the population of bacteria at 12 minutes. So 12 is our x. All right, so I'm just going to evaluate this in terms of x being 12. All right, so what we're going to do is this, 118.9 times 1.75 raised to the power of 12. And we can do that in our calculator. So I'm going to go 118.9 times 1.75 raised to the 12, and let's figure out how much bacteria we have here. Enter 98,093. All right, 98,093. .1. I'm going to put 0.1 just to round it off, man. That 5 told me to round it, so 0.1, 2 decimal places. But hey guys, I believe that concludes this test review. Yeah, that's it. So again, good luck, man. I hope this helped.